up, guys? Welcome back to erbsclass, 5 more minutes of math. Today we're still on that geometry, them 3D solids. Yeah, we talked a bunch about volume. We haven't talked about surface area. Yeah, so let's get to it. Oh yeah, surface area, prisms to be exact. So think of surface area as the area or the two-dimensional space on top of every surface of a prism, right? Think about if you were covering it with paper, or think about if you were painting the exterior of a three-dimensional shape. That would be surface area. Let's get a prism up here and talk more about it. Oh yeah, there's a prism. You know what kind of prism this is? What shape are the bases? Oh, you remember what the bases are? The bases are the two identical faces. These are the bases. Yeah, those are the bases. So the other faces on the shape are called lateral faces. The lateral faces. So on this triangular prism, we have the face going up this way, the face going up this way, and then the face around on the back. Yeah, so there are 3 lateral faces around the bases. Yeah. Before we get into the formula and everything, remember this prism doesn't have to be base on top of base. Now this prism can be laid down on its side like this. Yeah, exactly like that. And even though the bases are side to side, they're still the bases. Yeah, exactly right. So let's get to the formula, right? Yeah, there's a little bit to dissect here. And I actually forgot a couple of things. So there's a reason that I have total written here. So the surface area of any shape has a couple of parts. So there is the surface area of the lateral faces, or the lateral area, which is this part. Yeah. And then you have the area of the two bases. So in essence, this lateral area is the area of just the lateral faces. So think about this. This base right here, right? Let me outline it for us. Yeah, that base right there. So that outline that I drew around the base is the perimeter of the base, which you see here is capital P. Now imagine I took that outline, just the outline, and I raised it up through the height, slid that ring up through the height of this prism. What I would have is a tube that looks like a triangle. So that tube that looks like a triangle would be the lateral faces, and then therefore the lateral area. Yeah, exactly right. And then once I have the area of those lateral faces, because I took that perimeter and pulled it up through the height, slap a base on the bottom and a base on the top, and you got the total surface area. Now, depending on the problem, you may need just the lateral area, or you may need one base or two. So pay close attention to your problems, but everything you need is right there. Yeah, exactly right. If you're not the formula type, I know some people are a lot more visual learners and maybe they need a picture to work with. What if flatten this out? What do you think it would look like if I flattened this all out? Let's see. Yeah, think about deconstructing the solid to form a group of shapes. Yeah, and look, those are 3 rectangles and 2 triangles. I bet with the right numbers here, you can find the surface area that way also. Yeah, try it. All right, let's talk about a different kind of prism. Oh yeah, you've seen this before, our little circular prism that we call cylinders. Yeah, wait a minute, what was that formula before for the surface area of a prism? Let's get that back up here. All right, so first off, what are the shape of these bases? Are these bases circles? Yeah. Capital P, the perimeter of a circle. Don't we call it something else on a circle? What's the perimeter of a circle called? That. The circumference. So if the perimeter of my base is a circle, is the circumference, can I replace that? Oh yeah, just like that. And since we're on circles and capital B is the area of the base, how do you find the area of a circle? Yes, of course, that's how you find the area of a circle. So can I just swap that out? Yes, you can. So the surface area of a cylinder follows the same formula as the surface area of a prism. You just got to swap out capital P, perimeter of the base, circumference. Yeah. Capital B, the area of the base, pi r squared. Yeah. Now, what if you're not the formula type, right? What if I wanted to deconstruct this cylinder? What does deconstructed cylinder look like? Exactly what it would look like. So let's talk about what we have here, right? The surface area, or the area of all of these surfaces. Let's talk about the surfaces we have. I got 2 circles, radius r, 2 circles, radius r. Yeah. And then I have a rectangle, right? So the rectangle, you know, if you think about a cylinder, if you crack the cylinder open and lay it flat, it's a rectangle, right? If I slice the cylinder down here and lay it flat, it would be a rectangle. And I have the 2 circles on top, just like here. So this area right here that wraps around the circle, doesn't this area take up, when I wrap it around, is it the circumference of that circle? Yes, it is. So 2 pi r, the width of this, h is the height. Yes, that's exactly how you find the surface area of a cylinder. Either way, formula, break it apart. I'm cool if you are. Yo, listen, I hope this helps. Thanks for coming to check me out, man. I'll see you next time. Bye, guys. Oh, yeah.